YouTube, what's up? So it's been a while, and I always get, even today, I was doing a speech with some students in Napa, and the key persons they were like, well, they graduated now, they're new TT, and they're like, sir, you saved me in maths. But where were you for keep? But where were you for keep? So I'm so glad that we have Miss Nalini right here. I'm always getting comments that we should do some more stuff for keep. So we got Miss Nalini and we're gonna do some Cape Pure Maths. So those of y'all who are watching in the future, this is in time for your Cape Pure Maths multiple choice. We're gonna study some multiple choice. Those of y'all who are watching way in the future, it's still really good content. So you can just fall in and learn a lot in a short space of time here. Miss Nalini has been one of the first teachers in the student hub, and she has been in the maths department for a very long time, one of our top maths teachers. Were you the number one teacher last year in the student hub, Nalini? Yes, Miss Nalini was the number one teacher last year in the student hub in terms of volume. And so a lot of y'all may actually know Miss Nalini if you went through the CSEC level. So without any further talk, big up Miss Nalini. Thank you again, Nalini, and the floor is yours.
Yes, of course. Right, so good evening, everyone. So welcome to some Pure Maths multiple choice revision. So we want to make sure that we get ready for your paper 1, which I believe is scheduled for the 2nd of June. Yes, so we're going to do some multiple choice questions here today, making sure everybody is on the same page about paper 1. You have 45 multiple choice questions to complete, right? 15 from each module, 15 from module 1, 15 from module 2, and 15 from module 3. So 45 questions to do in 1 hour and 30 minutes. You are allowed to use a calculator, and this constitutes 50% of your overall grade, right? So make sure to answer all of your questions within the time limit. So we're going to go straight into doing some questions. You're going to keep your keyboard close to you so that you are answering the questions. Even though I'll be doing the questions on the board, I'll be asking you guys a lot of questions, right? So you're going to either type answer choice A, B, C, or D once you know the answer. So looking at the first one, we're taking a look at the first one and we realize they want us to rationalize. They want us to rationalize this fraction. So we have root x minus root y all over root x plus root y. So to rationalize, you are going to multiply both the numerator and the denominator by the conjugate of the denominator. So conjugate, I just switch that plus to a minus. Right, if you notice, your denominator is a difference of 2 squared. So we have root x all squared is simply x, minus root y all squared is simply y. In your numerator, you have root x minus root y multiplied by itself. So you can use the very easy binomial expansion to do this. Root x all squared is x minus 2 root x root y plus root y all squared, which is y. So looking at the answer choices, we just want to put this over here. So we get x plus y minus 2 root x root y. So root of xy all over x minus y. So that is answer choice A. Got it? Everybody, answer choice A. You can type your answer if it is that you're sure about that. Moving on to question 2. Hi, Xavier. The statement P, if P, then P or Q is best described as A. Is it converse, tautology, contradiction, contrapositive? Well, to do this question, we can use a truth table. So we have 2 propositions we see in P and Q, right? P and Q. And we also have P or Q. We'll do that first, and then we'll do the entire statement. If P, then P or Q. So let's just draw a little table here. Crazy. All right, so since we have 2 propositions, how many combinations of inputs will we have? Well, 2 to the power of 2 is 4. So true, true, false, false, true, false, true, false. All right, doing that pattern, make sure we don't miss out any. We want to first do P or Q. That's the conjunction, P or Q. Sorry, disjunction, right? OR, P or Q. That means that when we have two false, we get a false, and the rest of them is true. Next, we want to do if P, then P or Q. So we're looking at this column, then this column. We're looking for T and F to give us a false. We don't have any of those situations, right? So a true and a true will give truth. All of them will be true. The only time it's false is when you have a truth and then a false, which did not happen for any case. So all these entries here ended up being true. Since that's always true, I see the correct answer in the chat already. It's a tautology. A tautology means it's always true. Contradiction means always false, right? That's someone who's always lying. False, false, false. So this is a form 6 subject here, right? Form 6 is where you do keep your math. So if this seems strange, for a form 2 student, this is a form 6 subject. So that's why I should option B. Question 3. This topic is called reasoning and logic. P, Q, and R are the propositions such that P, it is raining, Q, the sun is shining, R, there is a rainbow. So we have an English statement that we need to turn into maths and symbols, because we don't like to write English words, we just like to write symbols. It is raining, that is your symbol P, and is the sun. The sun is shining, symbol Q. So P and Q, but in maths, it's the symbol and, right? There is no rainbow. In order to represent negation, that's the sign. There is no rainbow, not R. So P and to Q and not R. That's option C. Very nice, Kayla. That's option C, right? So make sure you got through with that one. This but here you'll have to put the and symbol. Conjunction. Not disjunction, conjunction. And it's like saying and there is no rainbow. Nice. So we go on to question 4. Says 3 root 20 minus root 45 plus root of 80 can be simplified as. So you're looking at your answer choices, you're seeing that all of them have a root 5 in it. So we can change these numbers, right? 20 can be represented as 4 by 5. Right? You want a perfect square multiplied by 5. So we're going to represent 20 as 4 times 5. We can represent 45 as some perfect square times 5. So that's 9 by 5. Root of 80, something by 5. That's 16 by 5. Using your third rules, you can split it up, root 4, root 5. Right? You don't need to show working for pure maths paper 1, but I'm just showing working to make sure everybody knows how to do the question, right? But you don't need to show your working. So root 4 is the same thing as 2. Root 9 is 3. And root 16 is 4. So we have 6 root 5 minus 3 root 5 plus 4 root 5. If it is that you take a look at the coefficients, 6 minus 3 is 3, 3 plus 4 is 7. So we have 7 root 5. Answer choice C is correct. Big up everybody who got that. Question 5. Given that x is less than y, where x and y are both real numbers, which of the following expressions is true? So we're talking about modulus. Modulus is always positive. So does this even make sense? Can a modulus, a positive number, be less than 0? Absolutely not. A modulus modulus of a number is always positive. Answer choice D. These would not work if it is you consider the negative side of things, or if you consider fractions, right? So it will be option D. Modulus is always positive, meaning greater than 0. Going swiftly along to question 6, we have this cubic polynomial here. It's divided by x minus t. We need to find the remainder. So you want to recall the remainder theorem, which says that, so if I let this be the function, right, this very long thing be the function, and I substitute the value of t inside of it, it's just multiple choice. I substitute t inside of it, I will get the remainder. So wherever I see an x, I'm going to replace it with t, wherever I see x. So I get t times t cubed, t squared by t squared. Whenever you substitute, you make sure to put it in brackets. So using your laws of indices, you get t to the power of 4 added to each other 4 times. When you add that up, you get 4 times t to the power of 4, which is option C. So that's your remainder. It is in terms of t. Option C is correct. Question 7 is logs. So you want to recall your log rules. Log of 16 to the base a is equal to 5. You're going to have to use what you are given in order to find what they want. So we have here logarithmic form. You can change logarithmic form to exponential form. Everybody knows how to do that, right? This is your base. This is your power. This is your result. So a to your power 5 is equal to your result 16. So if I were to make a the subject, I would have to raise it to some power, right? Both sides, I'm going to raise it to the power 1/5. 5 by 1/5 will give me this 1 here. So I'm doing that to both sides. A is equal to 16 to the power of 1/5. And we could fix that up a little bit, right? 16 is the same thing as 2 to the power 4. 4 times 1/5 is 4/5. Right? So I have that A is equal to 2 to the power of 4/5. That's what I'm going to use and substitute it inside here. So I get log to the base 2 of 2 to the power of 4/5. Using your log rules, everybody knows this power could go in front of the log. So it's going to get 4/5 times log of 2 to the base 2. And what's this value here? So this is CAPE Pure Maths multiple choice questions. So log of 2 to the base 2, that's right, Ronaldo, it's 1. So 4/5 multiplied by 1 is simply 4/5. Answer choice A is correct. Very nice. Kayla, that's the question 8. Right, y'all know your things. Y'all revise in your pure maths. So pure maths is a subject that needs a lot of practice, making sure that you understand all of the concepts. Your mind will be switching between different topics. So you have to get accustomed to that. You have to get accustomed to sitting for an hour and a half and your mind circulating through different topics in the syllabus to do the questions. Great. So we have a polynomial. Yeah, keep pure maths. We have a polynomial, P of x. This is it here. And P of alpha, the symbol is alpha, is equal to 0. What are the values of h in terms of alpha? Right, so we're given that when x is alpha, P of alpha is 0. So I'm going to substitute. Wherever I see an x, I'm going to put alpha. And this is equal to 0. What does this look like to you? It should look like something. Alpha squared minus alpha h minus 12h squared. You're just going to type 2 letters in the chat. It's supposed to look like something. Very nice, Killer. Right? It's a quadratic. It's a hidden quadratic, right? So you type HQ for short, hidden quadratic. So it's a hidden quadratic. I hope everybody here knows how to factorize a quadratic in one step. If you know how to do that, that saves your life in terms of the amount of time. You don't really want to do AC method. You want to know how to factorize in one step. The only way to get alpha squared is alpha by alpha. How do I get negative 12h squared? Well, if I do negative 4h by positive 3. Right? So this will give me negative 4 alpha h plus 3 alpha h, giving me negative alpha h. So it works. So I have either alpha minus 4h is 0 or alpha plus 3h is 0. So we need to find values of h. We're making h the subject. You want to treat alpha like a constant. Don't worry about it. You want to treat h as the main thing. Making h the subject. So h is equal to negative alpha over negative 4. H is alpha over 4. 3h is negative alpha. H is negative alpha all over 3. So with two values, anybody type the answer yet? Alpha over 4 and negative alpha over 3. That's option A. That's correct, Ishita. Option E. Kayla has it as well. Kayla Marie. Question 9. If the range of f of x equals 2 over x plus 1 is this, what's the domain? So they gave us the range. These are y values. We want the domain, which are x values. So these are your f of x values. So we need to work our way backwards to get the domain. Yeah, Miranda, that makes sense. You need to work your way backwards. So you're going to equate the function to 3 over 2. Right? Your function is 2 over x plus 1. You're going to equate it to 3 over 2 and work your way backwards to find the value of x. So we minus 1. Which gives us a half. Cross multiplying x is 2 times 2, so x equals 4. So we're starting off x equals 4. Well, option C is the only one with x equals 4, where 4 is in the domain. So we don't really need to check the rest. We're going to choose option C one time. That's correct, Ronnie and Virgil. So this is pure maths, right? So yeah, x equals 4. You don't even need to check the rest. You can check the rest if you want. If you substitute 1 inside here, 2 over 1 plus 1, that gives you 3. You could mentally check the rest to be completely sure. So you given the function f of x is equal to 3 to the power of x. We need to find the inverse. I have senior in time to do this question. How many steps involved in finding the inverse? Right? So I'm just writing these steps for you. You're not required to try working for paper 1, but you're supposed to know your steps. It's 3 steps. The first step is to let y be equal to the function. So we're going to let y be equal to 3 to the power of x. That's the first step. Easy step. Next step is to interchange your variables. So instead of y, I'm going to put x. And instead of x, I'm going to put y. So I swapped the variables. I interchanged it. X is equal to 3 to the power of y. Now I need to make y the subject. How are we going to do that? So I have 3 to the power of y, that y is in the power. How do I get it to come down? Is equal to x. I'm going to have to take logs on both sides, right? Take logs on both sides. We're actually going to take logs. So we have log of 3 to the power of y is equal to log of x. I took logs on both sides. I'm leaving out the base. I don't need a base because looking at the answer choices, they didn't include one. Right? Using your rules of logs, your log rules, that y could come down in front of the log. So I have y log of 3. This is separated by multiplication. So when I bring it across, we change operations. We change it to division. So I have log of x divided by log of 3. So that there, everyone, is your inverse function. Log x over log 3. Option A. That's correct, Xavier. Option A. Niceness. Question 11. Which of the following graph represents the function y is equal to the mod of 3 over x? First off, does everyone here know what this graph looks like? Y equals 1 over x. Like when you see that function, a picture comes to your mind about what it looks like. Nah, I don't know what the gradient system is looking like. The paper 2 was pretty good. So when you see the function y equals 1 over x, this is the picture that should come to mind. Right? Now you're seeing here modulus. When you see modulus, you should just be thinking positively. Right? You should think positive thought. There's no negativity here. Mod of 3 over x. Should I anything below that x-axis? Should I? Should I include negative y values? No, I should not. Right? Because I want a modulus function. Modulus is only positive, so everybody is above the x-axis. This graph, however, is y equals x squared. So that's not your answer. So David is correct. Option D. All right. The part that was below the x-axis, it got reflected on top. So this is the graph y is equal to the mod of 3 over x. So you're thinking positive. All right, everybody's supposed to be above the x-axis. Niceness, we have a function x squared minus 5x plus 6. We need to find the range. So with a quadratic, to find the range, you need to know the minimum or maximum point. This is a minimum graph, minimum parabola. You don't have to concern yourself about the x coordinate. All you need to concern yourself about is the y coordinate because they wanted range. All right, remember your turning point is negative hk. So all you need to concern yourself with is that value of k. Getting the feedback from my class, they love the formula method more than completing the square. For this one, I'll do the formula method. If it was a nice quadratic, I would have done completing the square. But completing the square is not that bad. So we're going to do the formula method. So you want to recall your formula, 4ac minus b squared all over 4a. So your eyes are tracking what's on the paper, right? A is 1, C is positive 6, B is negative 5. You take the negative with you. 4 times 1. So we get 24 minus, be careful here, minus 25 all over 4. So we get negative a quarter. Right? Let me write my fractions properly. K is equal to negative a quarter. So your turning point is negative h, negative a quarter. So if it is, I were to just paint a little picture in your mind, you have a minimum parabola, negative h, negative a quarter. So the range will be values of y that are greater than or equal to negative a quarter. All right, Virgil had the answer there. Option E. All right, so that's how you do that question. Question 15, 2 roots of the cubic equation, and -1 and -2, what's the third root? So we have 2 roots, -1 and -2. Given the roots, we can write down the factors. The factors would be x plus 1. If the root is -2, what's the factor? The factor would be x plus 2. X plus 2. Right, so when you solve, you got x as -1, x as -2. We don't know the third root, but we're going to find it out. We know that whatever goes in that bracket is a linear expression. Right? It has to be linear. We can write the linear expression as ax plus b. Right? Now look at it. When we expand this, multiply by ax, that has to give 2x cubed. Everybody see where I'm going with this? If I do the expansion, x times ax, I have to get 2x cubed. So that implies that a is 2. Right? A is 2. A has to be 2 in order for me to get that 2x cubed. Now I need to find b. So if I take the constants and multiply by each other, 1 by 2 by b, I'm supposed to get that -6. Right? 1 multiplied by that 2 multiplied by that b is going to give me -6. So b is -6 divided by 2. Let me just, again, ahead of myself. 2b is -6. B is -6 divided by 2. B is -3. So I'm going to replace b with -3. The other factor, this is a factor, is 2x minus 3. So what's the root? We put it equal to 0, solve for x, and we get that x is 3 over 2. Option C is correct. So y'all had that in the chat a long time. Right, so that's how you will work it out. Question 14. We have a logarithmic expression here. We need to represent it as a single logarithm. So when you do these questions, the first thing you're going to check for is if they're all in the same base. So log to the base 2, log to the base 2. We could represent 1 as what? Log to the base 2 of 2. Right, working this out, this is equal to 1. I didn't mess with it, I just changed it. Log 2 to the base 2 is equal to 1. If they weren't in the same base, you'd have to make sure that they are all in the same base by using the change of base formula. This 3 that's in front of this log, that could go in the power. But you're going to be careful to put that 2q in brackets. Raised to the power 3. Bracket saves lives out here, people. You can't just put 2q cubed. That's very different than 2q all cubed. That square is going to square that 3q. So log to the base 2 of 3q squared. 2 to 4 is 8q cubed. 3 squared is 9q squared plus log 2 to the base 2. So everybody's in the same base. When we subtract logs of the same base, what does that mean? When we subtract logs of the same base, we divide. So 8q cubed divided by 9q squared. But when we add logs of the same base, very nice of you. When we add them though, we will be multiplying by that 2. So all that's left to do is simplify. 8 by 2 is 16. Q squared cancel out with a q squared on top. So we get 16q at the top all over 9. And that corresponds to answer choice A. Right, Joshua, just take a look back at that. 8 by 2 is 16. 16q over 9. Option A. Question 15. Which of the following intervals is in the domain of a function? This is your function here. So question, when is a function discontinuous? Class, when is a function discontinuous? So I'll wait for answers for that. So looking at your intervals, remember these are in curly brackets, so it's a set. So it's the values of x between -3 and 3, not including -3, but inclusive of +3. You see, CSEC Maths children are worried. No, this is not CSEC Maths, so don't worry. That's why capital when the denominator is 0. I'm scaring the people, children, with some pure maths here, but pure maths is a very nice subject. You do it in Form 6 upon doing add maths. So it's not that scary. Once you know your stuff, nothing is scary. When the denominator is 0. So the denominator here is x squared minus 9. Looking at this, you're supposed to already recognize that that's a difference of 2 squares. So Jaden, you could recognize something. Difference of 2 squares, x minus 3 by x plus 3. So x equals 3 cannot be in your domain. X equals -3 cannot be in your domain. Why? Because if you were to put that inside here, you'll get division by 0, which is madness. So you can't include 3 and -3. This is including 3. So no. Now taking a look at your numerator, you have root of x. Right? For unit 1, they lie to you and tell you cannot find the root of a negative number. Okay. So can you include negative values here? No, you cannot. You will learn to do that later on in unit 2. But you cannot include negative values because they have root of x. So my option is only option 2, which is option B. Right? So how are you feeling about module 1? Functions, logarithms, polynomials, factor and remainder theorem. The maths is maths then? You're feeling comfortable with that module 1? So module 2 is your trigonometry, your coordinate geometry, your vectors. So deep breath in, let's do a trigonometry question. For what value of theta? So looking at the interval, you know whether theta is in degrees or radians. It's in radians. Satisfy this equation. What does this equation, what does that side of the equation look like? It should look like something. 2 cos squared plus 3 cos minus 2. That there looks like a quadratic, which you can factor. It's very nice, Steve. Right? It's a hidden quadratic. You can factor factorize that quadratic. So the only way to get 2 cos squared is 2 cos theta by cos theta. The only way to get 2 is 2 by 1, but you want -2. So I could have 4 minus 1 given 3. Right? So factorizing in one step really does save you a lot of time. So you have either 2 cos theta minus 1 is 0, or cos theta plus 2 is 0. So look at this side of it. Do I have any values of theta that satisfy this equation? Right? Cos theta equals -2. If I were to solve for theta, would I get any values? No, I would not. Why? Because you need to remember your cos graph. Your cos graph is trapped between 1 and -1. Right? Your cos graph lies between 1 and -1. So there are no values of theta for which cos theta is -2. You have no values of theta. Right? So it's trapped between 1 and -1. It's not a problem that it's negative, right, Shelby? It's a problem that it crosses that -1 and goes on to -2. It's okay if it's -1. It's okay if it's -0.5. All of that is okay. So when we make cos theta the subject here, we're going to get a half. We're only concerned about the value of theta that lies between 0 and pi. So without the use of a calculator, what is cos inverse of a half? You are allowed to use calculators for paper 1, but you should know this from your trig table. Right? Cos inverse of a half is 60 degrees, which we can represent as pi over 3. Right? Pi over 3. So check that one out. Pi over 3. Very nice. Pi over 3. 60 degrees. Niceness. Question 17. So we have an expression. This symbol here means equivalent or equal to, but more so equivalent. Okay. Taking a look at these two terms, does that look like something? This. That's supposed to look like something to you. That looks like something, right? Cos squared. A difference of 2 squares, right? Cos squared plus sine squared. Cos squared minus sine squared. This here, everyone, is a difference of 2 squares. Right? That is a difference of 2 squares. So I could factorize. Let me get some more space to factorize. Right? Cos squared to the power of 2. Sine squared to the power of 2. So this is a difference of 2 squares. So when I factorize, I'm going to get cos squared A minus sine squared A, cos squared A plus sine squared A. And then I saw the very popular trig identity, cos squared plus sine squared is equal to 1. So I can make that substitution. Right? Multiplying by 1 doesn't do anything. Right? So I have 1 plus cos squared A minus sine squared A. Right? What else y'all want to do to this? Looking at the answer choices, we want to really replace this sine squared with something because the majority of the answer choices only have cos squared. So we're going to replace sine squared with 1 minus cos squared. Make sure to put your brackets because that negative have to distribute. Right? Sine squared is equal to 1 minus cos squared. Distributing that negative you get -1 plus cos squared. One minus 1 is 0, cos squared plus cos squared gives us 2 cos squared. So answer is option D, 2 cos squared 8. So it's D. Right? So you want to recognize that this here is a difference of 2 squares. Next question. 8 sin theta minus 5 cos theta has a minimum value of. Now you would recognize these questions from paper 2, where you would take this expression and put it in a specific form. Everybody remembers those kinds of trigonometry questions. You would put it off the form R. I'm going to choose sine theta minus alpha. The reason why I put a minus is because the minus and the minus, they will line up. So when I compare, I wouldn't have any problems because the minus and the minus lined up. To find this value of R, it's the root of this 8 squared and this 5 squared. The formula, root of 8 squared plus 5 squared, 64 plus 25, which is the root of 89. That is the value of R. I don't need to find alpha, right? That is just going to eat up your time. You don't need to find alpha because that does not affect your Y values. We're only concerned about minimum, maximum. That is that there. They're asking about Y values. So the things in the bracket do not affect your Y values, only the X values. So your function is the root of 89 sine theta minus alpha. You want to recall that the sine graph, right, everybody here should know what the sine graph looks like. The sine graph lies between 1 and -1. For the sine graph, your maximum is 1, your minimum is -1. If I interfere what's in that bracket, that does not change any Y values, right? Theta minus alpha, that is only a horizontal translation. It does not affect the Y values. So it remains unchanged. However, if I were to multiply the entire function by the root of 89, that will affect my Y values. So I get root of 89 negative root of 89. So this here is my minimum. This here is my maximum. So there are some questions that ask for maximum and some that ask for minimum. This is minimum, so it's option C, negative root 89. Very nice. Right, so it's similar to it. So you get to get another feel of the question. It's like a whole paper, 2 questions shoved into multiple choice question. F of theta equals cos theta plus 3 sine theta. R is positive. It lies between 0 and 90. What is F of theta? Right, this is just multiple choice revision here, everyone. So we want to take a look at this side of the function. And represent it as R. Looking at the answer choices, we're going to choose cos theta. Would we choose it to be minus alpha or plus alpha? We would choose it to be minus alpha. Why? I'll give you the hint that you need to use the addition formula to expand this. So you're going to choose the minus. Very nice, Abby. Because when you expand it using your addition formula, it's going to end up with a plus in the middle there. And the plus and the plus will line up. So you don't have to concern yourself about signs. All right, so let's go ahead and expand it. Everyone here? You should do enough questions that you know the addition formula by heart, but it is in your formula sheet. Cos theta, cos alpha, that minus, it's a plus. R sine theta, sine alpha. This plus and plus lined up, so now you could compare the coefficients very easily. You're comparing coefficients of cos theta. So the coefficient here is 1. So when I compare it, I get that 1 is equal to r cos alpha, right? So I don't worry about the cos theta. The coefficients are 1 r cos alpha. So 1 is equal to r cos alpha. Right? Blank off the sine theta and concentrate on the coefficients. 3 is equal to r sine alpha. So we get two equations with two unknowns. We need to find alpha and we need to find r. So would I do equation 1 divide by equation 2, or would I do equation 2 divide by equation 1? Because order matters out here. Which direction to do it in? You're going to make sure that when you divide, you're going to formulate tan. So I do want to do equation 2 divided by equation 1. Very nice, Javier. Right, everyone? Equation 2 divided by equation 1. Don't just take it for granted. It's always 1 divided by 2. That is not the case. You have to look for the fact that you want tan. Right, so it's 3 divided by 1. So tan alpha is equal to 3. Alpha is tan inverse of 3. Another way of writing tan inverse is arc tan. Right, ARC tan. Right, so tan inverse of 3. So that is a value of alpha. And how do we find r? The formula is 1 squared plus 3 squared. So that's 1 plus 9, which is root 10. So therefore, the function can be written as r cos theta minus arctan 3. So what answer is that? Option E. Right? Theta minus arctan 3. Very nice. So you see why it's important to make sure that your signs match up. Right? Be very aware of your signs out here, people. Question 20. This here is proven identities. You want to prove that this is equal to one of these answer choices. So when it have these very large trig fractions, what it helps is you breaking it up. So you have your numerator divided by your denominator. Right? Breaking it up into one line, your numerator divided by your denominator. Look at the answer choice. It have nothing to do with tan. So let's make a substitution for tan squared. We can represent tan squared as sine squared all over cos squared. Next, we want to take these two fractions and make it into one fraction. Right, we seem to way through this. The denominator will be cos squared. So I have sine squared x over cos squared x minus cos squared x over cos squared x, which is 1. So I just turn those two terms into one fraction. And we don't like to work with division out here. We more so work with multiplication. So I could change that division to a multiplication sign. And what do I do with the fraction after? Changing division to multiplication, I invert the fraction after it. So I get cos squared x all over sine squared x minus cos squared x. And this cancels out with this. Right. We flip it. We invert it, reciprocate it, any word you want to use. So this numerator cancels with this denominator, and all we are left with is cos squared. Right, so a very popular question is, how do you approach proving identity questions? You take a look at what it is that you have. You don't have anything in tan squared, so your right approach would be to substitute something for tan squared, right? And make it into one fraction, division to multiplication, invert after it. Right? Those are some popular techniques in doing proving identity questions. Great, let's go on to vectors. Those trigonometry questions really hold us back. Given that the position vectors of the points P and Q, right? Three-dimensional vectors. Then what's the length of PQ? So we have position vectors. What are position vectors? If you were to tell me in words, what are position vectors? Oh, Salve is chatting to like your trick. That's very nice. Very nice, Ahmed. They start from the origin. Position vectors are relative to the origin. So this is OP and this is OQ. They are relative to the origin. Right? So yes, you can get the points directly from your position vectors. We want the vector PQ. So we are going to use our very famous law. It's called the triangle law. Right? Using the triangle law. If you're learning off the law, there are two ways to learn it off. One with a plus sign and one with a subtraction sign. Ensure to remember how you write it. For this one, I'm going to use the subtraction one. PQ is equal to OQ minus OP. Right? OQ minus OP. So I substitute. And now I subtract. So your eyes are tracking it. -1 minus 2, -3. 4 plus 1 is 5. 4 minus 8 is -4. So that is your vector PQ. They want the length. Another word for length is magnitude. Right? What's the formula? Magnitude of PQ. It's the root of -3 squared, 5 squared, -4 squared. So calculator quickly, let me know what that is. 9, 25, 16. And then whatever surd you get, you have to represent it. You have to simplify your surds. What's 25 plus 16 plus 9? 50. Root 50. We don't have a root 50, but we could represent it as 25 by 2. So 50 is 25 multiplied by 2. So we get the root of 25 multiplied by the root of 2. So we get 5 root 2. When we find length, we make sure to put little units here. Right, this is paper 1, so no one is concerned about units. 5 root 2 is correct. Very nice chat. 5 root 2 is the length of the vector PQ. 22, we have a curve, y squared equals x plus 7, and xy equals 6. They intersect at 3 points. The y coordinates of these points are so you definitely want to do a substitution, right? Substitution method. If I were to rearrange equation 2, I'll get x is equal to 6 divided by y. I am making x the subject because I am concerned about y coordinates. So I'm not going to make y the subject. I'm going to make x the subject. So I'm going to substitute equation 3 into equation 1. Substituting x, 6 over y. And we don't like fractions out here. So let's get rid of it by multiplying by y throughout. Y cubed is equal to 6 plus 7y. Bringing everybody on one side. Y cubed minus 7y minus 6 is 0. So this is not easy to factorize. It's a cubic. This is y cubed minus 7y minus 6. But because it's multiple choice, one of these are your answer choices. You know, the answer is staring back right at you. So you don't have to do the whole long method of trying to find it. You're going to start substituting values to see if it works. Okay, so let's try -2. So we're substituting y as -2 and seeing if it's equal to 0. -8 plus 14 minus 6. That will give you 0. So -2 is an option. So it can't be C, it can't be D. So it's between A and B. Persons in the chat saying A? Should we even check 3? No, we should check between -1 and 1 to see which one it is. So let's substitute -1. Because for sure 3 is going to be in there because it's in both answer choices. So we get -1 cubed minus 7 by -1 minus 6. Right, doing your math mentally, that's 0. So -1 is one of the y coordinates of the intersection points, not +1. 1 minus 1. You won't get 0. So the answer is option E. Very nice. Question 23. A curve has equation. Right. Unit 1. In order for you to differentiate this, you would have to have a knowledge of implicit differentiation, which is a unit 2 topic. And I remember this question. This point is not even on the curve, so you can't even find a tangent. If you were to substitute x as 0, that will give 0 minus 0 plus y cubed. You will get y cubed to be 0. So you'll get y to be 0. You don't get y to be -3. So this point is not even on this curve. So you can't even find a tangent. Right? But to do the question, everyone, to have done the question, I think think about that this point have to lie on the curve. To do the question, you'd have to do something called implicit differentiation. Right? Because you have two variables here, x and y. And net 2. Right? So if I have any question. So just moving forward to normal questions. Question 24. we have a vector u has magnitude 4 root 5 units and is parallel to this vector. A unit vector parallel to u is, all right, so we have a vector v, right? This is bolded. I'm not sure if you could tell. It's those are vectors and it's bolded. When you see it on your exam paper, it will be bolded. That's because it's typed. You are not a computer, so you will write the vector v with a line underneath it. The vector u is parallel to the vector v. What do you know about parallel vectors? What's the property or the relationship between parallel vectors? Parallel vectors are scalar multiples of each other, right? So let the scalar be some value a multiplied by the vector v. They are scalar multiples of each other. So we can let u be equal to a I hat minus 2a j hat, right? That's the vector u. And we need to find what this a is. Let's go ahead and find the magnitude and compare it with 4 root 5. So magnitude of u is equal to the root of a squared plus the root of negative 2a all squared. A squared plus 4a squared, that's the root of 5a squared. So root of 5, root of a squared, so it's root 5a. I'm going to put that a in front, right? Root of a squared is a root 5. And they told me that the magnitude of u is 4 root 5. So comparing, what's the value of a? Is 4, right? So I've just found the value of a. You don't really need to go through the entire working of finding that a is 4, but because you have the 4 root 5 here, but you want to be sure, right? You want to be absolutely sure. If you find the magnitude of this, it will give you root 5. So the magnitude of u is 4 root 5. So you could have done it in your mind and said a is 4. But I just want to do the working to make sure that a is 4. So when I substitute back here, u is equal to 4i hat minus 2 by 4, 8j hat. Right? I have found my vector u. Now I can go ahead and start doing the question, which said a unit vector parallel to u. Everybody remembers the equation for that? How do you find a unit vector parallel to u? You have to take the vector u and divide it by the magnitude, right? So you have to, let me just write it out. A unit vector parallel to u is, you're going to take the vector u and divide it by the magnitude of u. I know it's looking very, very weird and stuff, but don't get bogged down by formulas. You're taking the vector and dividing it by the magnitude. The vector is 4i hat minus 8j hat. The magnitude is 4 root 5. They told you that. So we could actually factor out a 4 from the numerator. So the 4's cancel, and I get this root 5 is in the denominator. So 1 over root 5 multiplied by I hat minus 2j hat. A unit vector parallel to u is 1 over root 5 I hat minus 2j hat. So you can let me know if you get with that question. I want this a little long, a little too long for my liking. Right? You need to find that scale factor. They are parallel vectors. So that scale factor was 4. 4i hat minus 8j hat is the vector u. To find a unit vector parallel to you, this is the formula. You're taking the vector and dividing it by the magnitude of the vector. And after that is just computation. Nice. Let's go to question 5 with some circle coordinate geometry. A circle is defined by this. The gradient of the normal to the circle at 0, 0 is. So this here is the standard equation of the circle. Can anyone tell me what is the center? The center of the circle is -2, 0. And just for fun, what's the radius? Very nice, Tabitha. And the radius is not 4, but so this is of the form x minus a all squared here, Zabi. Right, so that's why a is -2. That's 2 units. Right, that's your radius. So they are asking you, like, you should have a idea of what things look like. So that's your circle. The center is -2, 0. And we have the point 0, 0. So where should that lie? First of all, that is on the circumference. That's the point 0, 0 with a radius of 2 units. They are asking you for the gradient of the normal. Gradient of normal, gradient of radius is the same thing. So if you understand it diagram-wise, you don't need to do the working. What's the gradient of a horizontal line? You can do the working, you have 2 points, but you look at it via diagram and you'll be able to tell that the gradient of a horizontal line, that's correct, Amit, 0. Right, make sure to read the question, they ask for gradient of the normal. If that's a gradient of the tangent, well, you would have to say infinity, but they ask for gradient of a normal. Question 26, the equation this, cut the circle with equation this in 2 distinct places. Right? You have 2 circles intersecting at 2 different points. What's the equation of the chord? All right. So how do we find intersection points? We will have to equate both equations. So let me just take a little minute to write it out. This is one circle equal to this is the other circle. All right. So now let's simplify some terms. X squared could cancel out on both sides. Y squared could cancel out on both sides. Bring in the -8x across. That's positive 8x. Bring in the negative y across. That's positive 8y. Bring in the positive to the 1. That's minus to the 1. So simplifying, we get 6x plus 2y negative 30. I don't know why I stolen on that. Right? 1 minus 31 is negative 30. So 6x minus 2y minus 30 is equal to 0. Or we need to divide by 2 throughout, right? There's a factor of 2 hidden here. So we get 3x plus y minus 15 is equal to 0. Where's my answer? It's option C. Right? That's a chord. A chord is a straight line. 3x plus y minus 15 is equal to 0. Lovely things. Question 27. About the equation of the line which passes through this point and is parallel to the vector v is which of these? Everyone here knows the vector equation of a line? Everyone knows the formula? Who wants to tell me the formula? So 4, negative 5, 7. 4, negative 5, 7. The vector equation of a line, the formula is R is equal to A plus lambda, lambda is a scalar, multiplied by M. M is your direction vector. So this is the formula you're supposed to know, right? R is equal to A plus lambda M. A, you can get that from your point. That's a position vector OA, 2, 0, negative 6. I write it vertically. M, your direction vector, is 4. Don't forget your negative 5, 7. So substituting, for negative 5, 7. I tend to write it like this because it's easier to see the numbers clearly. This is what we call matrix form. We like to see the numbers clearly, but in your answer choices, they like the I hat, J hat, K hat business. So just write it back. 2 hat, we don't have any J hat, minus 6 K hat, lambda into 4 I hat, minus 5 J hat plus 7 K hat. Option D. Here, this is your direction vector. It goes here. Lovely. Question 28. We have the set of values of K for which the straight line intersects the curve at 2 distinct points. Right? So you have a curve. This is when you see this, you should recognize that's a quadratic and that's a straight line. Can anyone tell me something about 2 distinct points? I'm looking for specific something. What does it say about the discriminant when your line intersects the curve at 2 distinct points? Very nice, Amit. B squared minus 4ac is greater than 0. That is what that means, that your discriminant is positive, it's more than 0. So I'm going to equate the equations. I'll get this. And now I'm going to bring everybody on one side. So I get minus kx minus 2x. Bring the minus 4, it becomes plus 4. So I get a quadratic where A is 1, B is negative k minus 2, and C is 4. Right? Everybody, I don't need to write that. A is 1, B is negative k minus 2, and C is 4. So now you could substitute it into this inequality. Expand. Right? Expanding this, you're going to recall your binomial expansion. So you're going to get k squared. 2 by 2 is 4k. 2 is 4. Minus 16. Right? So simplifying, you get k squared plus 4k. 4 minus 16 is negative 12. Right? This is a quadratic, which you can factorize in one step. Lots of things happening in this question. I want positive 6 minus 2k to give positive 4k. Lovely. So what are my critical values? Right, you got a quadratic. So the first thing you need to do is find your critical values. Your critical values are negative 6 and positive 2. So if you were to recall how your number line looks, negative 6 happens first, and then the positive 2 happens. Right? I'm just drawing a little sketch here. negative 6 happens, and then the positive 2. So it's a minimum parabola. That's what you have to get me to draw that right now. And we are looking at the part of the graph that is greater than 0, that is above the x-axis. So I'm going to look at this part and this part. So how would I write my solution set? It's the values of k, not x, right? K. It's the values of k such that k is less than negative 6, right? Less than, because we're not being inclusive here, less than negative 6. And, sorry, or k greater than 2. Right? K has to be less than negative 6 or greater than 2. So let's see what answer choice is that. K is less than negative 6 or k is greater than 2. Answer choice C. Right? So that's quite a question. Question 29. We have a vector A, 5i hat plus 12j hat. What's the unit vector parallel to A? Again, we call the formula. All you do is you take the vector and you divide it by the magnitude of the vector. Right? So if it is that I wanted the magnitude of A, it's the root of 5 squared plus 12 squared. So some of you all here would just know automatically that that is 13 because of your Pythagorean triple, 5, 12, 13. But if Pythagorean triples is not your thing, you just work it out, you get 13. Right? So the magnitude of A is 13. So how do you find the unit vector parallel to A? You take the vector and divide it by the magnitude of the vector. So you take 5i hat plus 12j hat and divide it by 15. That 15, if I were to divide it by 15, is the same thing as multiplying by 1 over 15. Right? So 5i hat plus 12j hat. That is option B. Let's move on to question 30. I find this paper long. You see, section 2 really slows you down. Section 2, I think, is the tougher part of the modules. So we have the angle. What is the angle between this vector and this vector? Everybody knows the formula to do this question. Right? Again, if you don't like the I hat, J hat, K hat, you can write it as matrices, as in matrix form. What's the formula to do this question? So we have U and V. The first thing we need to do is find the dot product. U dotted to V. So 4, negative 5, 1 dotted to 3, 6, negative 1. So when you find the dot product, you multiply the corresponding entries and add it up. Negative 5 by 6, 1 by negative 1. So we get 12 minus 30 minus 1. 18, 19, negative 19. And then you have to find the magnitude of each of those vectors. So magnitude of U, four squared plus negative 5 squared plus 1 squared. So your calculator helps you to do all of those things. 16 plus 25 plus 1. And you get the root of 42. Right? Your calculator will help you. Root of 42, leave it as a root. Leave it as a third. Right? So that's the root of U. Next, let's find the, sorry, when I say root of U, I mean mod of U, the length of U. The magnitude of V is 3 squared plus 6 squared plus -1 squared. So it's long, but it's not going to, take up a lot of space in your brain to work it out. It's pretty easy to work this out. 46. So we have the dot product, we have the magnitudes. So what's the formula? The formula came to mind already. The formula is cos theta is equal to u dot v all over mod u mod v. So it's -19 all over root 42 root 46. So that's equal to cos theta. So theta is cos inverse of all of that. Root 42, root 46. Right, all of that. Plug all of that into the calculator. Right, hopefully you guys have the Casio calculator. Comes in very handy for doing these things. If you have the sharp, you need to make sure and use brackets. Right. So writing your answer to 2 decimal places, it'll be 115.61 degrees. Answer choice A. So that is module 2 multiple choice questions. Module 2, you need to make sure and allocate more time to do module 2 because module 2 a bit longer than the module 1 and module 3. Which one will you all say is the easiest? Module 1, 2, or 3? I would say module 3. Well, they say module 1 is the longest, but it's the easiest. Module 3 is the shortest. If you're good with differentiation and integration, module 3 is very nice. Module 3 is calculus. So let's get started with this. We have y is equal to 2x minus 1 to the power 4. We need to find the second derivative. To do this, I hope everybody here knows the shortened form of the chain rule. So to find the y dx, you bring down the power, you differentiate inside the bracket, you put it back, bring down the power, differentiate inside the brackets, you put it back, well this here, you put it back and -1 from the power. So you get 8 by 2x minus 1 cubed. I need to differentiate again. Leave the 8 alone. Right, I'm going to say bring down the power. Differentiate inside the bracket. You put it back. -1 from the power. So knowing the shortened form of the chain rule is going to save you a lot of time here. 48 multiplied by 2x minus 1 squared. All right, so 2x minus 1, right? 2x minus 1 to the power 4, 2x minus 1 to the power 2. This is root y. Okay, so if it is that I had 2x minus 1 to the power 4 raised to the power of a half. Do you agree that that's the same thing? 4 multiplied by a half is 2. What's in the square brackets is y. So we get 48 root y. Answer choice D. When I differentiate tan, what do I get? Do you all know your rules? If I were to differentiate tan, I'm going to get sec squared, but I have tan 5x. So you have to treat this like brackets. Differentiating inside the brackets will give you 5. Differentiating tan will give you sec squared, put it back, sec squared 5x. So my answer is option B. Very nice. Steve, 5 sec squared 5x. Nice. We have y is equal to this expression. We need to find the second derivative. Right? That's symbol for second derivative. That means you're going to have to differentiate twice. Bring down the power, 4 3s 12 minus 1 from the power. If I differentiate sine, I get cos. Differentiate inside the brackets, I get 6. Leave the 3 alone. That 3 is a constant. It's not bothering anybody, leave it alone. Differentiate inside the brackets is 6. Differentiating sine is cos. Right, so that is dy dx. Let us differentiate again. Bring down the power, 12 2 is 24, minus 1 from the power. Leave the 18 alone. When I differentiate cos, I'll get negative sine. That's 6. When I differentiate inside those brackets, I'll get 6. That 6 comes in front here. Negative sine 6x. So I simplify, a minus and a minus makes a positive 18 by 6. Well, looking at the answer choices, I think it's 108. Sine 6x. Option D. That's right, option D. Very nice. Question 24. So you're given h of x and we need to find h prime of x. That simply means the first derivative, h prime of x, the first derivative. Right, so everyone here knows the shortened form of the chain rule, right? We don't need to go through the whole tralala of doing chain rule. So the shortened form is you bring down the power, differentiate inside the bracket. If I go to differentiate inside here, I get 4x cubed. You put it back and you minus 1 from the power. 4 3 is 12x cubed. Option C. Very nice. Limits. So I have limit of a function as x tends to negative 4. If I were to substitute negative 4 inside here, what would I get? Because that's the first thing you're going to try. You're going to try substitution. Right? That's the first thing you have to try. When you try that, mentally working it out, you're going to get 0 over 0. That is what we call indeterminate form. So we need to try something else. We need to try factorization. So looking at your numerator, that's a quadratic. X by x. 6 by 4. So I want negative 6 by positive 4. Yeah. Let's also factorize the denominator. Yes, it's indeterminate. So x by x, 9 by 4. So negative 9 by positive 4. So these factors, they cancel out. And we remain with the limit of this as x tends to negative 4. So now you could go ahead and substitute negative 4 minus 6 over negative 4 minus 9. So negative 10 over negative 13 is positive 10 over 13. Option B is correct. Question 36. The volume of the solid generated when the area enclosed by the curve y equals x squared, the y-axis, the line y equals 4, is rotated a whole revolution about the y-axis. So you know, sketches really do come in handy so you could get your thoughts in order. Y equals x squared is this entire thing. But we are only concerned with the y-axis, the line y equals 4. Let me take on x. And y equals x squared. right? So when the area enclosed by the curve y equals x squared, the y-axis and y equals 4, that is rotated 360 degrees. So this point here will be at 0, this point here will be at 4. We are finding volume about the y-axis. Everybody remembers the formula? Pi, don't forget your pi. Integral between a and b of squared with respect to y. Because you will dy here, a and b have to be y limits. Your y limits are 0 and 4. X squared is equal to y. So all I have to do is substitute y here. When I integrate, remember now you have to switch your mind to integration. When you integrate, you add 1 to the power and divide by the new power between the limits 0 and 4. You substitute your upper limit minus your lower limit. But just so you know, you see constant, that go outside. See that division by 2? That goes outside. So it won't clutter your working. So you have pi over 2. You have 4 squared minus 0 squared. 4 squared is 16. Pi over 2 minus pi over 2 multiplied by 16 is 8. 8 pi. Right? So my volume is 8 pi. Option A is the answer here. Right? So make sure you know your formula. Make sure you know that you have to substitute y limits. And you're good to go. A curve C is given by this pair of parametric equations. What are parametric equations? There are 2 equations, one in x, one in y, with a third variable, sometimes t, sometimes theta. We need a Cartesian equation. Right? For a Cartesian equation, I only want an equation with x and y. So I'm going to make sine theta the subject. I get x over 4. I'm going to make cos theta the subject. I get y over 3. And for these kinds of questions, you want to recall your very popular trig identity. Sine squared plus cos squared is equal to 1. Substituting, you get x over 4 all squared plus y over 3 all squared is equal to 1. When you square something, everything in those brackets are being squared. So you get x squared over 16 plus y squared over 9. We don't like fractions here. The more math you do, you don't like fractions. So you're going to multiply by the LCM of 16 and 9, which is 144. Right? You're going to multiply by 144. You're going to get 9x squared plus 16y squared is equal to 144. Option C. Yeah? Question to the 8th. Question to the 8th. Asking you for the first derivative of cot 2x plus 1. Okay, so if you didn't know, now you know that when you differentiate cot, you're going to get negative cosec squared. All right? When you differentiate cot, you get negative cosec squared. So you have to account for the fact that you have some brackets here. Differentiate inside the brackets, you'll get 2. So let me just put that negative here and put that 2 there. So negative cosec squared and put it back. And differentiate inside the brackets will give you 2. Cot is negative cosec squared. So negative 2 cosec squared of 2x plus 1 is answer choice A. They like to write it as CSC, because that's how you type it, CSC. But we write cosec. I write cosec. Write the whole thing. Question 39. We want to differentiate x cubed sine x. Cube sine x. We have two terms that separated by multiplication in terms of x. So what rule comes to mind? The rule that comes to mind is your product rule. So you're going to let u be equal to x cubed. And that's right, v be equal to sine x. You need to find du dx as well as dv dx. Differentiating x cubed is 3x squared. Differentiating sine x is, positive, cos x. Now you're going to have to write down your rule. All right, so using product rule, dy dx is equal to u dv dx plus v du dx. So substituting u as x cubed, dv dx as cos x, v as sine x, and du dx as 3x squared. Taking out the choices, you want to factor out x squared. So let's do that. We're going to be left with x cos x. If I take out this x squared, I'll be left with 3 sine x. So what's my answer? X cos x. You know, sometimes you get the correct answer, but you're hunting for it now because the answers are so close. Option D. That has happened to me already, where you get the correct answer, but you just get bamboozled by how close it's looking, and you circle the wrong thing. Right? Option D. For which of the following values of x is the function discontinuous? So you're going to remember your theory that a function is discontinuous when the denominator is 0. So you get either x plus 5 is 0, so x is negative 5, or x is negative 3. All right, if you were to substitute these values inside here, you'll get division by 0. So it'll be discontinuous at those points. 5 more questions, everyone. We have the graph y equals ln x. The gradient of the normal to the curve y equals ln x at x equals 2. So this is a tangent, this is a normal. Right, tangents, normals, perpendicular to each other. Question, when I differentiate ln x, what do I get? Your curve is y equals ln x. So when I differentiate it, dy dx, these are one of your special cases. Differentiating ln x gives you 1 over x. So you want to find the gradient of the normal at x equals 2. Yeah, that's correct, Amber. So I can substitute and find the gradient of the tangent, right? Dy dx gives you gradient of the tangent. So the gradient of the tangent is 1/2. What's the gradient of the normal? Right, so you want to recall the theory that tangents and normals are perpendicular. The gradients of perpendicular lines, if I were to multiply them, I'll get -1. Right, the gradients are negative reciprocals of each other. So the gradient of the normal, negative reciprocal, right, -2. Excellent. All right. Do ensure to read the question. See how they bolded for you? Sometimes students just go straight on with the 1/2. You want to read your question, ask yourself, did I answer the question? Gradient of normal is -2. A curve is defined by this equation, given that x increases at a rate of 1 unit per second when x equals 1, what's the corresponding rate of change for y? When you hear the word rate, you need to think with respect to time. 1 unit per second. The x per second with respect to time. They are asking for the rate of change for y. They are asking for dy dt. You have something with y and x. So your third variable is x. These questions incorporate the use of the chain rule. So this is your function. You want to differentiate it with respect to x. Bring down the power. Differentiate inside the bracket, so it'll give you -2. Put it back and -1 from the power. Type of 20. Right, that is the y dx. You want it when x equals 1. So substituting 1 minus 2 by 1 is 20 by -1, which is -20. So you have a value for dy dx. So you're going to use your chain rule to find dy dt. Dy dt. The third variable is x. So you're going to have dx here and dx here. It's important you know how to write the chain rule. So when it cancels, you get dy dt. So dy dx is equal to -20. The x dt was given as 1 unit per second. So dy dt is -20. Answer choice B. Right, that's chain rule, rates of change. Question 43. The portion of the curve y equals 2x between x equals a and x equals b is rotated 360 degrees. So that's 1 revolution about the x-axis. The volume V of the solid generated is best represented as, this is a straight line by the way, about the x-axis. So you need, don't forget your pi, you need a and b to be x limits, which they are. X equals a, x equals b of y squared with respect to x, right? Respect to x, this is about the x-axis. So we need something for y squared. We have y is 2x. So y squared will be 2x all squared, right? Squaring everything in those brackets, which will give 4x squared. So looking at the answer choices, put that 4 outside, right? Constants could always go outside, or they could come back in. So we get 4 integral between a and b of pi x squared with respect to x. When you put with respect to x, a and b are x limits about the x-axis, right? Everybody matching. The x-axis, a and b being x limits. Niceness. Question 44. Cos cubed 3x squared minus 1. That's your function. What is f prime of x? Meaning, what is dy dx? You're going to differentiate. Now, those who have a really good understanding of the shortened form of the chain rule, they could do it. But I'm just going to do the chain rule. This is your function, right? So I'm going to let u be equal to whatever is in the bracket. U be equal to 3x squared minus 1. F of x is y. I'm going to just use y. Cos cubed of u. Cos cubed of u. So u is equal to 3x squared minus 1, y is equal to cos cubed of u. So you want to find du dx. Let me just bring this down to make some space. Right. I want du dx. Du dx is equal to 6x. dy du, you bring down the power, right? You have to apply shortened form of the chain rule. Cos cubed u and cos u to the power 3 is the same thing. Bring down the power, differentiate inside the brackets. Differential of cos u is negative sine u. Put it back, minus 1 from the power. Right? So hopefully everybody see what I did there. Bring down the power, differentiate inside the brackets, you put it back and minus 1 from the power. So you get negative 3 sine u cos squared u. So using your chain rule, dy dx, or in other words, f prime of x is equal to dy du times du dx. So dy du is this whole thing. Multiply by 6x. 6x by negative 3 is negative 18x. Do I leave my answer in terms of u? Absolutely not. I need to replace it back with this entire expression. So sine of 3x squared minus 1 cos squared of 3x minus 1. Well, I should already cos squared first, right? So this is the answer here. Negative 18x cos squared sine 9. Last question, everyone. Getting your answer for the last question. Amit has been holding it down. We have the gradient of the normal to this curve at x equals 1. So this is your curve. We can differentiate it. dy dx is equal to 6x minus 2. We can find the gradient of the tangent when x is 1. Substitute. We get 4, but that's the gradient of the tangent. What's the gradient of the normal? Right, so that relationship is popularly tested. Gradients of tangents and normals, they are negative reciprocals of each other. So it's negative 1 over 4. So the answer is option B. And yeah, that was the last one there. And you guys have now completed 45 multiple choice questions for Pure Maths Unit 1. We want to also do another 45 questions next week, Friday. That will be Friday the 30th. Friday the 30th of May at 6 p.m. The 6 p.m. is Trinidadian time. So if it is that you're in Jamaica, that will be 5 p.m. Jamaican time. Yeah, you could vibe it over, watch it over. When you watch recordings, you watch it at a faster speed, like 1.5. It goes a little faster. In terms of the questions and the I have the solutions here as well. This will be posted on the Student Hub Discord channel. It'll be posted in the WhatsApp groups, right? So that you can, if you want to watch the solution itself, what it's supposed to look like, you have it here in a document to just vibe. All right, but you're not gonna show work in for. You don't have to present your work in. You do need to write your work in to organize your thoughts. So with that, thank you all for coming out today for some Pure Maths multiple choice. And I shall see you next week for some more questions. No problem at all. Bye, Joshua. Bye, everyone. Bye, Amrit. All right, good night to all. So next week for another session. I'll just be doing some more multiple choice. And let me just let Mr. Springer know that I am complete here. Just give me 1 second. So, Steve, I'll message you. Right, so it will be another 45 multiple choice questions. And I'll message you with that.
So next week, same time?
That's it.
Wait. Yeah, next week, same time. All right, wait.
At 6 p.m.
Okay. All right. Well, thanks, miss. So wraps up nearly like 2 hours. Okay, so next week we'll hit them at next 45. Love and blessings, everybody. Thanks, Miss Nalini. Good luck in exams.
No problem.
Your maths people, hold it down.